When are two figures congruent? All right, that's our. We know about triangles, inside, outside. Fine. Know how to name them. When are two figures congruent? So right away up here, I have two quadrilaterals. One I call ABCD. One I'm calling WXYZ. This statement right here is saying that they are congruent. Okay. So what does it mean if two figures, two polygons, are congruent to each other? I'm going to use a term that's familiar. I want everyone right now to take quadrilateral ABCD and put it right on top of WXYZ. So sides and angles match up. All right, so sides and angles match up. So visually, if you can, take quadrilateral ABCD, put it right on top of WXYZ. Match them up for me. And I'm tired of saying match them up or match them up. All right, what I want to do is say correspond to each other. So tell me what sides would correspond to each other. Give me a side from one that would correspond, match up to a side of another. All right, and this is on your own, on your own. Stop looking for help from everybody else. Here we go. 1, 3, left, 2, 0. Brendan, give me two sides that would match up. XW and CD, love it. So CD matches up with X, which one? XW?
I said CB, XW.
CB, sorry, yep. Let me go CB then. CB matches up with XW, got it. Now, because the figures are, listen, because the figures are congruent, so are these two sides that correspond. But the figures have to be congruent first, all right? Give me more sides that correspond to each other. Ooh, Tess, another pair that correspond. Okay, I'm fine with those. AB matches up, aka corresponds with WZ. Because the figures are congruent, so are those corresponding sides. Keep going. Give me another pair that correspond. Bailey, go ahead, another pair. DA, YZ. Love it. DA, YZ. And the final pair that correspond to each other. Vinny?
DC and X1.
Okay, yep. So if I know two figures are congruent, the sides that match up, the sides that correspond are also congruent. Now do angles, because the angles are also congruent. You give me a pair of angles that correspond now. Bailey, back to you.
C and X.
Yes. So angle C is congruent to angle X. Give me another pair that match up, correspond. Got to stop saying that. Lily?
Angle D and angle Y.
Yes. More. One more pair here. Give me another pair that correspond. Bailey, back to you on fire today.
Angle A and angle W.
Angle A and be careful.
Oh, angle A and angle Z.
There you go. Good. Yep. And I'm not going to call in anybody else. Process of elimination. Angle B corresponds with angle W. So is everybody starting to see? If I know two figures are congruent, all sides and all angles that correspond are congruent. Now I have a secret to tell everybody. I called on a lot of people there to give me the sides and angles. I did not even look at the diagram to see if they were right or wrong. But I knew they were right. I didn't look at the diagram to see if they were actually matching up. If CB and XW actually matched up. If C and X actually matched up. I did not look at the diagram. And no, I didn't memorize it from last period either. Let me fill you in on my secret. That given told me everything. Here's why. Take a look. CB, do you see the position of C and B in the first quadrilateral? What's in that same position in the next one? WX. All right, everyone look, C and X. Notice C is the third spot, X is the third spot. Okay, this right here is called a congruence statement. It is powerful. It will always be written in the same order as the sides and the angles are. You are going to write your own here in a couple minutes as well. Okay? So the congruent statement will also show you what sides and angles match up. Do you see what I'm saying? My secret here? Like the first two letters are AB, so I know they're going to match up with the first two letters here, ZW. Right? There's the little secret there. So when you guys are going to write your own here in a minute or two, you got to make sure when you write it, you can't just write it in whatever order you want. You got to make sure that all the sides and angles match up when you write it. Questions? Okay, here we go. Buckle up. This is one of my favorite couple days here in this unit. Decide whether the triangles are congruent, and yes, we are going to put it in a proof. Before we do anything, don't start marking or writing anything. Let's just talk here. How are we going to show those two triangles are congruent? By showing all the angles, all the angles, and all the sides that match up are congruent. So how many sides are there right now? In a triangle, how many sides? 3. So we need to make sure all 3 pairs match up and are congruent. How many angles in a triangle? 3. We got to make sure all the angles are congruent. So we got a lot of work to do. So let's start off by marking everything in the givens. B and D are right angles. Mark them. And what do you know about right angles? Okay, they're 90 and they're also what to each other? Ooh, there's a pair, right? Right, there's a pair. AB is congruent to ED. Hash mark time. BC congruent to CD. Double hash marks. AC congruent to CE. Triple them up. And as you guys remember, I know it's been a few days, but that's all given. Whew. You're welcome. All sides are taken care of, aren't they? All the sides are taken care of. So the only thing I need your help with, get all the angles congruent now. Because if you can get all the angles, the triangles will be congruent. What do we already know about B and D? They're right angles. So I can now tell you what in step 2. Yes, they're right angles, but also now they are congruent to each other. Angle B, congruent to angle D. Anybody remember the fact add up on the board, unit 2? Lexi? I didn't have that. I had something about right angles, though. Simon?
The right angles are congruent.
All right angles congruent. All right, turning it over to you guys now. I have 1 pair of angles. I need both pair. I need all 3 pair, though. Can anybody see any other angles in this diagram based on all our discussions since Unit 1 that have to be congruent up here? Give me another pair of angles. This is on you guys. I'll help you with the last pair, but you got to find another pair for me that are congruent and tell me why. Based on all our discussion here. You know, I just got to drag it out of you. What's up, Liv?
A.
What's your reason going to be? What do you mean corresponding? If I have what type of lines? What? Go ahead, keep going. What type of lines do I need? All right, and I don't have any parallel lines here. Good. And that's what everyone always says: corresponding, alternate, interior. But I don't have parallel lines, so that's out. Dylan, you got a pair of angles, maybe?
BCA and ECB.
Yes. Don't tell me why. All right, don't. I'm gonna have a classmate. Dylan says, "Hey, look at those two. Hey, we need to be. Hey, we got to be at this point where we notice what type of angles there are. Therefore, they're congruent." All right. Some of you, I don't know if you know what type of angles those are yet. All right, and that's a little concerning right now. Angle BCA congruent to angle ECD. Dylan gave me what type of angles there? And this has got to be an instant when we see them. What type of angles did he give me, Cormac? Vertical, right? Vertical angles? Vertical angles are congruent. Okay? We've got to start seeing those right away. The opposite angles formed by 2 intersecting lines. All right, now I'll take over now. We have the right angles. We have the vertical. The only pair we don't have and we still need, we can't skip it, We don't have angle A congruent to angle E. We still need it though, all right? Or the triangles aren't congruent. So let me take over here. You don't have to write any of this down here. I'm going to show you why they're congruent. How many degrees in each of these triangles? 180. Everyone agrees? Let me don't do that. Let me do a right triangle instead. $90, $90, $20, $20. You guys just said they have to add up to what? 180, right? Don't both of these angles have to be the same? If I already have two pairs of angles that are equal, doesn't the third pair have to be equal? Because they have to add to what? They have to add to 180. Okay? And that is how we are going to get the third set here equal. Angle A congruent to angle E. And I'm going to introduce a new fact called the third angles theorem, which we'll write down at the bottom of your packet here in a second. Third angles theorem. And we're not done with the proof yet. We're not done with the proof. So let's just write down what this third angles theorem is. You guys have a little box. I don't. Here's what the third angles theorem says. If two pairs of angles are congruent in two triangles, then what did we just show? If two pairs of angles and two triangles are congruent, then the third pairs are. The third pair are. That's not good English. So that's how, if you're still looking for a third pair of angles, that's how we're going to give it. Oh, let me make something clear, because some people try to use this inappropriately. This is the third angles theorem. There is no such thing as the third sides theorem. If I have two pairs of sides, automatically the third pair, get out of my house. Okay, that's garbage. All right, no such thing as third sides, only for angles. Only works for angles. So let's go back up here, finish our proof now. Do I have all, ready? Check. Let's check ourselves. Do I have all three pairs of sides congruent? Yes, that was given to you. Do I have all three pairs of angles congruent? Yes. So if I have all of that, now I can say the triangles are congruent. But be careful. Remember what we talked about. When you write this statement, the sides and the angles must match up correctly. So the first thing I'll ask somebody is, just name one of the triangles any way you want. Okay, let's start out. 1, 3. John, you just got back. Jonathan, not going to get you here. 2, 1. Lauren, name one triangle any way you want. Triangle. Okay, way to be creative. Good. Triangle ABC. Congruent too. Now, you can't just call the second triangle anything you want. It's got to match up. What's angle A correspond to? Angle E. So A. E. What's B correspond to? D. Up. And then the other one that's left? C. And then look too. Do the sides match up? Let's see. AB in the first two spots should match up with ED in the first. Yep. Let's see. Last two, BC and DC. Yep. They match up. Okay. Does everyone see what I need when you write this statement? And then here's what we're going to write. Definition of congruent polygons. When all three pairs of angles and sides, you have congruent polygons. And this goes for triangles, quadrilaterals, but we're going to stick in the triangles. Anything here? Oh, what's that? Some of you didn't have breakfast. You're hungry? You're hungry from, I'll feed you. Don't worry. Here's another one. Here we go. I know you're hungry for another one. Here it is. Prove these two triangles congruent now. Prove these two. Again, rules don't change. You got to get me all three sides and all three angles somehow. And I'll give you some information. You're welcome. Okay, what did I give you here? CG and DG? CG, DG, congruent, congruent. CN, DN. Boom, 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 boom. Ooh, angle C, congruent to angle D. And what's that symbol in between GN and CD again? GN and CD, what's that symbol I put in between? Perpendicular. What are you putting on your diagram then? Box, right angles, right? All right. Let's make them congruent. How many angles did I tell you were congruent? Watch your mouth here. Watch your mouth. How many angles were you given congruent? Just one, right? I can't include the right angles. I didn't tell you they were congruent. That's your job. So why don't we start there? Can I put in step 2 that those right angles are congruent? No, I'm not ready yet. What do I still need to tell you? Before I say all right angles are congruent, I still need to tell you what in the proof. They're right angles, right? I need to tell you they're right angles. Hey, last proof, I didn't need to do it because it was in the givens. If you're going to tell me right angles are congruent, it is a two-step process. The first step is telling me they are right angles. So go ahead, give me the names of those two right angles. Lily, you're up. Give me the names of those two right angles. Angle GNC and GND are right angles. Got to tell me they're right angles first. It's always a two-step process. Anybody remember the reason why we used to put? I usually took 2 different reasons. Henry?
Parallel lines form.
What type of lines?
Parallel. Oh, no.
Watch your mouth.
Perpendicular.
Perpendicular lines. Anybody use definition of perpendicular too? That's also fine. Yep. Perpendicular lines form right angles. Then you tell me they're congruent. Again, guys, 2-step process with right angles. Tell me they're right angles if it's not given, and then tell me they're congruent. And we just used this in the last proof, all right angles congruent. Everyone look at your proof now. How many angles are congruent now? How many angles do you have congruent now? 2. So that means I got one more pair to prove. How am I going to do that? Come on. You have 2 pair already congruent. Third angles theorem, right? There's no way you're going to get those top angles congruent unless we use third angles theorem. Name those top angles for me. Name them. What do we got? Henry, name those top angles I still need. Angle. CGN, perfect. And NGD, fine with me. And I don't know if anybody's thinking this in their mind and you just don't want to ask it. When we write the angles and the sides, I don't need those to match up. It's the triangles at the end that need to match up with the letters. And again, this is because of the third angles theorem. Oh, we're rolling here. So all the angles are taken care of, right? Okay, now look at your proof. How many sides are congruent? How many pairs of sides? 2. So I need that other pair congruent. But remember, don't even think about writing third sides theorem. Get out of here. Can somebody name the sides? I'm still looking to get congruent. What are the sides in each triangle? Let's go triangle CNG. Triangle CNG. What's the side I still don't have congruent yet? What's the side I'm still missing? NG, right? I still need something about NG. And go to the other triangle. What's the side I'm still missing? Wait. I'm missing NG in both? That's what you guys are telling me? NG in one triangle, NG in the other. What do I know about NG and NG? Oh, they're the same, so they have to be congruent. That was the first thing I showed you, which was what property? Whoa, we got it. There it is. Do you see how this side is shared between both? So it's got to be congruent to itself. NG congruent to NG, reflexive. Okay, so if a side, and it could be an angle too, is shared by both triangles, that's congruent by reflexive. And now we have everything we need. We have all three angles and all three sides, so here we go. Let's write a correct statement. Write a correct congruent statement. Here we go. Lily, you name that first triangle any way you want. Go ahead. Angle.
Oh, sorry, triangle CGN.
Triangle CGN. Congruent to, now match it up, everybody. Match it up. Lily went CGN on you. Match it up. So if we call that first triangle CGN, how are we going to match it up and call the second triangle? Ooh, Cormac, go ahead.
DGN.
DGN, yeah, it's nice when they have a side in common. It's easier to match it up. Definition of congruent polygons. Okay, so make sure you have all three pairs of sides and angles. One more thing we need to do as a group. One more thing. I want to make sure you're good at this congruent statement. All right, whoa. Before we put pen, pencil to paper, are these two triangles actually congruent? Do I have all three pairs of sides? Yes, they're all marked. But I don't have all three pairs of angles marked. I have D and Z congruent. I have F and P, but I didn't mark H and R. Are they even congruent then? Did I even need to mark H and R? Why not? Come on. Wrap this all up today. Why do I not need to do H and R even though I know they're congruent? Let's go, Bailey. What do you have? Darn right, third angles theorem. Get at it. Good. Everyone good? I don't need to mark it. Third angles theorem. Okay, they're congruent already. So go ahead. Here we go. Somebody start me with the first triangle. Finley, name it any way you want. FDH. All right, everyone. Saddle up. We go FDH. How you naming the next triangle? Again, make sure the angles match up that correspond. Angles and sides match up. Angles and sides. All right, we're going FDH. What are we calling the other triangle? Ooh, Lauren, let's go. Finish this off right. What do you have? PZR. I have no, let me write it down and check. F and P match up. D and Z match up. Good. How about the sides? FD and PZ. Awesome. DH and ZR. Looks like a good one. Way to go. Anybody else? Okay. I know I'm really grilling you tonight. 4 questions. Let's get it done. Here we go.